So you did a short introduction about me. So I was curious about this presentation because it's a little bit different versus a presentation which we had yesterday. But thanks, you did some introduction about OpenStack, OpenShift, and this stuff, which is, in my opinion, going to the cloud is very important aspect of real-time services, and I'm gonna to tackle this topic right now. About me, so I worked many years for DT Group in T-Mobile, working in Poland, cooperated at group level. We know Sebastian for many years from that time, leading something what was called Open Development Community. It still exists. I'm surprised and happy about that. Then moved away from this, let's say, pure telco world and worked 2 years for Telestacks, and then came back to Poland and working for OVOO and OVOO. Okay, I forgot to mention. Privately, I'm ultra runner. So I'm doing this, let's say, crazy stuff, running 2 days without sleeping and so on. About OVOO, it's Polish company. We grown organically. It was set up in 2012 by 2 co-founders, and we are providing services mainly to mobile operators like T-Mobile, Orange, Play. However, we are building Avocado. It's our brand for products. And what we were able to do, we consolidated almost all technical skills in who are able to develop in Java. We don't have Erlang developers. They are all in Sweden. But in terms of Java, yes, I suppose that we have the strongest team maybe in Europe. Our customers, as I mentioned, we have as well customer in Saudi. Shortly, our products. So we have OCS. This is something what I'm really happy about and proud that we are able to take our experience and implemented application which is cloud native. And so this is actually subject of this presentation as well. Messaging gateway is implemented in the same way. However, we have such stuff like service broker, prepaid call control, TAS, MMTEL, you know, this stuff, which is known from telco world. And it's short recap of the presentation which I had last year. It was more theoretical. Right now, I'm going to show after 1 year how what happened. So first, the data demands are growing, and here's nice slide showing. I hope so that you see it, but it shows between 28 and 24. Sorry, 18 and 24. Depend on region. It goes like 6, 5, 9 times more data consumption per month. So Alan said that 4G is enough. I agree, but if we take into account that in few years we will consume much more data, and this is definitely true, the 4G is not enough. We don't have enough density. This is the problem. That's why, of course, this is huge hype about 5G and so on, but at the end of the day, it's about how your data can be delivered, either from big antennas or smaller ones which are around us and can provide us a lot of data. different use cases. I don't want to bother you about that, but the important is that except you, watching Netflix, YouTube, we'll have such use cases like self-driving cars. Somebody can think, okay, this is dream, but those cars are now driving. Maybe not at public transport, but yes, we have such cars already. And there are different use cases which require extremely low latency. This is important to understand that. Different use cases, VR, augmented reality, and so on and so on. Huge data consumption. So on one side, we are consuming a lot of data. On the other side, we would like to have extremely responsive service. And this is something what is hard to achieve using current technologies, which are in backend. But what are real market drivers? This is what is happening now. This picture about this fire is something what happened in Poland at the beginning of this year. It was 31st of January, and whole data center, the biggest one of the biggest operator in Poland, burned completely. Actually, it wasn't the problem of data center, because data center was here, and here was some storage, and this storage was the problem. But at the end of the day, 500 racks were flooded because a fireman wanted to do something. The problem after that was that except many platforms which were there, they didn't have geo-redundancy. It was one problem. The second problem was that they were implemented in a classical way, deployed in a classical way. So redeployment them in another location was like 2 or 3 weeks of working, 24 hours, and people were sleeping in data center and doing this job. Other problems like that, trade war. So nowadays people think, okay, maybe Huawei is not the best choice for my stack, so and so on. We don't know how it will, what will be the result, but people are starting to thinking which technology, which solution we should use. We are about before. It depends who you ask, but let's say financial crisis. There is some rumor about that. So at the end of the day, we see that we have to be lean and we have to react quickly. Technology drivers. So from the development process, application architecture, the technology is changing. And it is mostly, let's say, in the IT world. TELCO is right now concentrated at creating standards. This is good, but the question is that we have enough time to do so. So that's why I showed different angles. What is happening? Where we should go? What is the problem with current deployments? And so lack of service separation. We have, let's say, common middleware, and we have few services which are working on top of that. And if something happens wrong with one of them, then we have problem. Monolithic big applications, heavy. The consequence is we have heavy regression testing because inter services dependency. The deployment process is complicated. Heavy acceptance testing. and scalability. It was hard to convince customers about scalability because voice is not scaling. The traffic is quite stable, but in new services, it is something what is crucial because then we don't know how customers will use services. And few examples. Sorry, this is, let's say, something to show you what I mean. So let's suppose that we have something what is called SDP platform, and we have few services. Nevertheless, what services they are? Let's say prepaid, VPN, some number translation, and so on. And then something happens with one of them, and actually we have a problem and emergency because the whole platform is impacted. And this is real case. So if you want to deploy new service, it's a lot of testing, regression, and so on, because everybody is scared about those services. Nevertheless, what this service do? It could be some proof of concept, which we would like to realize in, let's say, 6 weeks in Scrum mode. It's not possible, honestly speaking. People are scared about deploying new services in network, and if you want to have, let's say, a new version of service, then we have to replace some common libraries and so on, which impacts other services, another use case. If we want to have some specific service for niche customers, then it's again we can do this proof of concept, but we are not able to do that quickly because people are scared about the platform because that can impact other services. And the last topic is low latency. And right now, if we have customer who is using the service, let's say it's at home network, is using service from backend or internet. In a visited network, can have to go through home network and then backend and internet. And imagine that we would like to deploy a vehicle to X or VR service. So if we have it here or here, the latency, you can imagine what is like 200, 300 milliseconds, something around that. Not sure that it can be faster, and for such services, it's not acceptable at all. That's why we have to think about edge cloud. This is space for edge computing, and deploy those services either at the edge of home network, or I found last time very reasonable use case showing why we should deploy services at the edge of visited network. So imagine that you are US customer and traveling to Asia and using service from US. Imagine that you have to go over the ocean. It's not acceptable from latency, from quality perspective, and so on. That's why those services should follow you. If it doesn't matter that it will work or not. I mean, from the perspective, because edge computing is still something what is huge hype. We don't know still how it will be realized, but at the end of the day, this is kind of cloud. And we have to understand how to deploy services quickly in the cloud. What we believe, and this is actually what we verified, we believe in evolution, not revolution. So we've seen such projects which were about to do revolution. After 2 years of working, nothing happened. But you can start doing stuff on your field without huge impact. So from my field, we are providing services mostly for mobile operators in the field of voice services, SMS services. Those guys usually they're using some kind of middleware like JSLI, SIP servlets, or legacy platform. So I don't want to say, okay, guys, get rid of that. You should do this cool stuff. It's not possible because they invested money, so they should utilize as long as possible existing platforms. But meanwhile, do hybrid deployment, like to use legacy and think about cloud native deployment. And then in 21 or 22, move away from that and be purely cloud native. And how to do that? Actually, the problem with telco right now is okay. We are happy about that because we know this stuff, but the problem is that telco is using those protocols like SS7, SIP, diameter, SMPP, which are not fitting to cloud deployment type. In the cloud, you should go to REST-like communication, and using Kubernetes containers, you are not able to attach a SIP session to Kubernetes directly. Maybe somebody can do that, but for me, it's really hard. That's why we see that we should have something what is in front. And actually, we are coming back to the concept of service broker, and this is actually how we are deploying services. But you have this legacy protocol here, and then here either you have some legacy application or legacy platform, or new application which is implemented based on REST communication, and this is how you can migrate from legacy platform towards cloud native deployment based on profile, and you can support legacy protocols at the edge of your application. This is important to understand. You can easily scale it. Your core can load balance traffic between different instances, so you don't have this constraint like right now. So this is actually our service broker, which we are using in most of our deployments to create this concept. And right now the question is, okay, my customers are scared about going cloud native because they don't have platform, and this is actually the biggest mental problem. I don't have platform, so what is this application? Actually, we understand that, and we don't want to say, okay, I have few developers, they will implement some application, then we will deploy on the platform and on the cloud, and it works. No, we understand that we have to have alarm module, replication of data session replication. We have to have data cache. If we have few instances, they have to understand each other, what is the state of the session, and CDRs, logging, and so on and so on. On top of that, depend on type of service. If we are using SIP diameter SS7, we tested the solution using akka. Akka is reactive toolkit to implement actor model. This is the same model which was used in Erlang, but as I mentioned, with Erlang is the problem that you don't have too many Erlang developers. They are all in Sweden, but in Java, if you learn your team how to implement real-time services using akka, you are able to do that quickly. For REST applications, we are not actually. Akka is not needed there. We can rely on Spring Boot or any other type of framework which allows build quickly REST applications. This is, for instance, something what we implemented in our customer, and but the same, you need alarm, statistics, replication, and other services which are around. Sorry, it's really small, but you can check it later on. And what are results? Because this is something what I can show many times, but the important is how it actually works. And my presentation was about lessons learned. And this slide I created 1 year ago. I use it without changing, so that so our OCS, which I mentioned, was deployed in September 2018. Right now, we finalize implementation of messaging gateway to replace the existing legacy solution. And this is the cloud deployment in Saudi, working on 2 data centers, handling traffic in average 1000 TPS with some peaks to 2000 if we have like marketing campaign or something like that. So we are able to consume such traffic, and it was promised that the latency will be about 20 milliseconds. But what happened? I checked it before coming here. This is the real graph from Elastic Kibana. So we have average latency at OCS, handling diameter 3 and 4 and 5 milliseconds in average. So you can imagine that without this heavy stack like middleware and so on, you are able to achieve such results. This is incredible. Honestly, I was shocked, but this is how it works at the production, and it shows that you are able to achieve those demands to have edge computing at the edge of your cloud. But the important is how you tackle the way how you implement your service. So here is about OCS. So it's implemented, as I mentioned, based on Akka. We are using, let's say, this microservices type of implementation. It's Dockerized. Right now, we are moving to Kubernetes to achieve bigger scalability. As I mentioned, the diameter stack, because it's a session protocol is at the edge of Kubernetes, and then we are converting it to REST. Internally, we are using REST-like communication. So this is this. Let me show off GA for our messaging gateway, which is implemented the same way. So this is modular architecture where we have integration with OCS. We have message store for store and forward, and we are using Cassandra. It's quite good technology. We have message bus, which is based on Kafka. This is another good example of using open source technology. And we are using Akka as well here for managing communication with SMPP, which is legacy, so it's outside of Kubernetes cluster. HTTP can be directly sent to Kubernetes, and right now we have implementation of SMS gateway, so we are able to handle A2P traffic for SMPP. HTTP traffic, and here is what is our blueprint. Sebastian, you are aware about blueprints, but this is actually something what, in my opinion, is important to draw. And our architects, they don't have to think how to do that. They are using existing blueprint. And so our vision is, not vision actually, what we are doing is like, you can deploy any stack. So we have experience with OpenStack. We can deploy such cloud, by the way. But we can deploy a public cloud like Amazon, Azure, VMware, bare metal. And if you have such diversity, you need to automate deployment. So we are using depend on customer, because this is another problem, that some customers would like to use Terraform Ansible, which is quite good combination. But on the other hand, more, let's say, telco customers, they are focused on OpenStack, Chef, Heat, and so on. In the middle, we have Kubernetes, because we believe that Kubernetes and Dockerized application is extremely good from the cost perspective, because you can fine-tune your deployment. You don't have to allocate virtual machine. You can allocate many instances at one virtual machine, and this is something what we see that is important. So the overall cost of your solution is lower. And then you can start build your PaaS, platform as a service. So as I mentioned, you need to cut off somehow legacy protocols. Then you can implement your service layer using either Spring Boot or Akka or any other type of technology. We are not strict in here. It's rather related to the way what service is doing. Then we need some data layer, either cache or session using Hazelcast or Aerospike or any other fast in-memory or efficient database. Then you need to keep subscribers using some relational database, Postgres, MySQL, or whatever. You can store your objects in Ceph or Swift, and at the end of the day, you need overall OEM layer like Logstash, Elasticsearch, Kibana, Prometheus, and so on. So this is something what is important, that you need this. You have to build it for each service. And lessons learned. Yes, you can do it. My opinion, it works for real-time services. Not in my opinion. Actually, this is true. So you shouldn't be scared about. Is platform still needed? In my opinion, no. You should think about building services which are able to be deployed on the edge of the cloud. And one important lesson learned is automatization is extremely, maybe not extremely, actually is expensive, because you have to do this whole scripting. Guys, this is crazy. It's like it's a lot of work, honestly speaking, but it pays off once you'd like to do extension, do test platform, pre-production platform on another site, and so on and so on. This is important. At the first time, it's expensive. Later on, you can use it. And you have to be ready for a quick deployment and scalability. Okay, thank you.